We have with us Mr. Yash Rane from TrueVenture.ai, who will be talking regarding the role of cloud manufacturing in Industry 4.0.
Hi everyone, my name is Yash Rane, and welcome to Additive Manufacturing Industrial Conference. I am taking a session on on-demand manufacturing, and I'm representing TrueVenture in this event. Just a quick background about myself. I'm an entrepreneur. I started my company called Chisel, which was into cloud manufacturing of 3D printing back in 2014, which was later acquired by TrueVenture, and since then I'm a part of this company. I'm a mechanical engineer. I've done my graduation from IIT Roorkee, and I'm an active volunteer in ASME India as a student operating board member. Spending a few seconds on about our company, TrueVenture is essentially a B2B marketplace for manufacturing companies to manufacture custom parts. It's very much similar to Amazon, where you have a buyer and a seller. In our case, a buyer is a typical manufacturing company like OEM or Tier 1, and a supplier is a job shop, a Tier 3, Tier 4 company who are in the business of manufacturing part. Our job is to essentially help customer manufacture the custom part and help the supplier in growing their business and solving the day-to-day operations problem of manufacturing. My today's agenda is essentially to share and discuss possibilities of cloud manufacturing or on-demand manufacturing. Both of these terms are used interchangeably. Uh, and while I'm going through the presentation, there are 4 to 5 points that I'll cover, which is hardware versus software, just giving you a glimpse of how the software industry is progressing and where we are in terms of manufacturing, how cloud manufacturing essentially works, a basic framework of that, what are the developments and challenges happening in the cloud manufacturing space, what's the Indian context, and just leaving you on a high note of what's the future of manufacturing, just thinking out loud. Right. So let's start off with where we are in terms of manufacturing. We all know about that we are in an industry 4.0 stage. But if you look at the progress from industrial 1.0, 2.0, and 3.0, there are most of that was more of an evolution. Starting from 1.0, where we have just learned how to utilize water and steam and generate power. Industrial 2.0 was more about using that power, using electricity, and get into the mass production. Industrial 3.0 was about automating the processes. When we look at 4.0, it's about making manufacturing smart. It's about making manufacturing accessible, and it's about manufacturing on demand. Right? Now, let's take a step back and let me give you an example of a comparison between hardware and software industry. Right? And I think this slide depicts very well what's happening in software. Let's say if you're a software company, it's very easy for you to launch your product into the market because everything is available on demand. Everything is on the cloud, and you can just make something and push it into the market. But in hardware manufacturing, it doesn't work like that. You really have to go through a long process of designing a product, making the prototype, doing rigorous testing on the prototype, and then go back and change the design and then launch the product into the market. It takes anywhere between 1 to 2 years, in contrast to 1 to 2 months that takes in the software. So we are really not hitting the progress when it comes to hardware development. It's still not an easy game. And when you look at manufacturing today, there are three basic problems that every manufacturing company is facing, right? Increasing efficiency. It's a never-ending problem, right? Everyone wants to be more efficient. The second important point is shortening time to market. Companies want to go to the market as fast as they can. And the third most important point, which we as a consumer don't experience, is flexibility. Companies in the manufacturing business wants to be in a situation where they have to keep minimum inventory. They can respond to the demand in the market and really ramp up and reduce the supply accordingly. It's a very important point. Now, when you look at a cloud today, right, I'm trying to break up cloud manufacturing into 2 words. What is cloud? A cloud is nothing but a system which is deployed on server, and with it comes a basic advantages, right? It's accessible 24/7, it's secure, it's agile and flexible. You can use as much as you want whenever you want. You can collaborate on cloud. You have automated updates, unlike the traditional servers where you deploy things and there are no regular updates coming. And paper use as much as you want to use. Now, combining all these features with manufacturing, where we are essentially assembling the components and manufacturing those parts with a machine, right? Let's see what exactly a machine is and how cloud manufacturing actually impacts the machines that we use today on the shop floor, right? When you look at manufacturing from 30,000 feet, we only think of a shop floor where a lot of parts, or assembly line where parts are getting assembled, right? Multiple parts coming from multiple suppliers and assemblies happening. And we are talking about robots, automation, IoT, a lot of things like that. And that is what Industry 4.0 is. But if you break it down further, right, these assembly line has sub-assemblies. The sub-assemblies have parts. and these parts are getting manufactured through different manufacturing process. So if you look at this band, this is where cloud manufacturing is essentially impacting. It's not impacting an assembly line, it's impacting the actual manufacturing of parts that happening through different manufacturing processes. And to just put it in a very simple words, cloud manufacturing is a network of manufacturing infrastructure managed by intelligent platform to enhance efficient and effective utilization of resources. We'll come back to this definition again in detail. Let's talk about what is a machine, a cloud machine specifically. It's nothing but a CPU. And we all know a CPU has a RAM, it has a processor, it has a space, and it has some brand like Dell or anything like that. It's a machine. And just to give you a comparison, there's also a manufacturing machine, right? A sheet metal machine, a CNC machine, a 3D printer for that matter. They are all machines. They have a material specification, they have a size, they have an operational capacity, they also have a brand. If you can draw some comparison between these two machines, they are dumb set of machines, right? And machines are commodity. When we talk about cloud and manufacturing, we are essentially trying to use these machines, connect them together, and build a network so that again these machines are accessible, secure, pay per use, automated updates, and so on and so forth. And I'm going to leave that thought with you. How many applications you can think of with this situation, and again give you a contrast. The cloud servers had been put together and they can be utilized today. We all know AWS for that matter. And what happens when we connect all the manufacturing machines together, right? It's a small snapshot of all 3D printers put in one factory and digitalize. What I'm trying to say is that these machines are starting to talk to each other now. And the advantages again is they're accessible 24/7. They're agile and flexible. As much machine as you want to use, whenever you want to use, there is no limitation in the tradition in comparison to tradition. You can use it remotely and you only pay for what you use. Right? Now let's spend some time on cloud manufacturing framework. How does it really work? A cloud manufacturing is a combination of three things. There's a manufacturing setup, which is a traditional factory. There's a network, and there's an intelligence involved in that. So when we say network, it's like combining those factories. The third is intelligence, where with the job shops having the network, there's some level of knowledge or intelligence that exists into the system. Let me explain a little bit in detail. Whenever there's a company, an OEM or tier one, they design a product. So there's a product life cycle, right? Traditionally, these product life cycle, these companies have their own supply network, which they work with. The knowledge is essentially restricted to this company about their product. So they don't have a knowledge of who are the other suppliers in the market. Are there suppliers, can the other suppliers can give better costing? What are the spare capacity of these new suppliers? So the knowledge is very restrictive and small, because of which they don't get all the benefits. With cloud manufacturing, we can put these OEMs, we can put the job shops, and we connect them to a single platform. And we actually collect the data through the entire transactions that are happening in a traditional workflow. Once we have that knowledge, we can deploy a cloud manufacturing server that can actually help the companies to get new services from the job shops and get more data. Similarly, these job shops can get better customer outreach and also get a lot of customer insights whom they want to work with. Right. I'll skip this slide because I think it will be a little bit complicated one. But I think, yeah, this is much a simpler slide, right? So if you look at the technology infrastructure for cloud manufacturing, it essentially starts with information management. I think information is the key when it comes to cloud manufacturing. You have a base of the knowledge base, the information. What that knowledge and information is about the machines that has a calibration, that has raw material, that has standards, and the data and knowledge about that machine that can be utilized as and when we require those machines, right? And it can have much more data like design and softwares about the suppliers, about the processes and things like that. On top of this data information layer and machine information layer, there is a monitoring system whereby we are monitoring these machines using IoT devices and capturing that information into a feedback loop. So for example, if I give an input to a machine, we would get to know how that machine has responded and having a feedback loop onto this part. If we are able to stack these three modules on top of each other, we are able to achieve quality parts through the cloud manufacturing ecosystem, right? And to give you the real-time use case, at TrueVentor, how we are trying to do it. So at TrueVentor, we have built a platform, as I've explained. We have a buyer and we have a seller. A buyer essentially comes and uploads a drawing onto a platform, and on our platform, we have a knowledge base. This knowledge base essentially looks at a drawing and then tells you how much it's going to cost, who is the right supplier who can manufacture this part, what are the challenges that you might face in manufacturing that part. And this information is getting better through the feedback loop that we have inbuilt into the system, right? And just to go back again, if you look at the second layer, right? Which is nothing but the information about the machines. We essentially have that information coming through the network of qualified job shops that we have handpicked. We have connected those machines to our system, and through which we are able to capture the data and capture smart insights about the supply chain. Right. Now, if you look at the entire workflow, starting from a CAD design to the manufacturing of part, the main advantage a cloud manufacturing platform builds in is number one, cloud data extraction, which is the ability to read a drawing onto the cloud server, which is one of the main value add. The second is the costing timeline feasibility, like how much it's going to cost, how much time it's going to take, and whether the part is manufacturable or not. And third is generating a manufacturing instruction, giving to the job shop so that job shop doesn't have to spend time in identifying how this part has to be manufactured. All these three informations are in a continuous loop. So every time we pass on the data through this process, we extract the parameters. Those parameters goes into the knowledge base, and then we do the check whether the previous knowledge base and this new data are they matching or not. And if there's a desync, then it goes into the configurable self-learning rules and standard. And this system keeps on going on and on and on. That makes the cloud manufacturing smarter. Let's talk about why it is important to delve into cloud manufacturing today. The first advantage is because we have a better internet accessibility now. There are so many logics and algorithms that we have to run to make cloud manufacturing happen. Internet is the baseline, right? We have a smart computing technologies out in the market, and the machines are getting smarter with the IoT devices, right? Uh, there has been a survey which was conducted that talks about that how important cloud manufacturing is at the design and prototyping stage. And hands down, I think 90% of them said that yes, it's useful, but there are challenges on cloud manufacturing even today that is impeding its adoption. The number one point is security and privacy. We are talking about uploading the data on a cloud server, which most of the companies are still not comfortable with. Most of the companies are still used to of having the data on a server, which is put into their own factory. People are not comfortable putting the data outside of their factory, right? They are not very sure where the data is going to reside. I think this is one of the big questions that we keep on getting on cloud manufacturing. Where does this data go? Does this data stay in India? Do we have a server based in US or Europe, right? And that data is going out there because we are handling the critical information of manufacturing, CAD data, the R&D projects which are going on. It's very sensitive data, right? The third is support services. What happens if anything goes wrong? What happens if you place a platform on a cloud manufacturing network of a manufacturing? And what happens if the order goes wrong? What happens if the quality is not proper? Who takes care of the logistics? So the entire support services infrastructure is where the trust is not built yet. And the last is the adoption. And this point is more on an Indian context where we are still getting used to of using internet in our day-to-day businesses. Right? That actually brings me to my fourth point, which is the Indian context of cloud manufacturing. There are so many things happening on cloud manufacturing across the world. So many companies are launching new initiatives. But when we look at India, right, India is a home to 60 million MSMEs operating today. 60 million is a huge number. And if you look at these companies, 96% of them has a turnover of less than 1 crore. Now, if we talk about digitalizing these kind of manufacturing companies whose turnover is less than 1 crore, it's a big challenge, right? You cannot go with traditional use cases, which have been successful in USA and Europe and other developed countries. You need something different. And one of the key points is smartphone-based systems, right? So we are not moving away from cloud manufacturing, which is working just fine, but how to actually make it contextual to Indian use case. And mobile phones are the key. There has been huge adoption in using WhatsApp in day-to-day businesses when you think of manufacturing job shops. And these companies have also started adopting digital tools like online payment, right? Just doing the accounting online or looking at how much sales has been done. But most of these things has been done using a mobile phone, right? Uh, in my last context, I would spend some time in how we at TrueVenture are trying to build a cloud manufacturing platform. And trust me, there are multiple ways to go about it. There are multiple use cases. We have talked about machines, network, and intelligence, and there are multiple use cases that we can bring in. But at TrueVenture, we are building a platform where a company can essentially come and place a requirement of manufacturing onto our system. The moment it comes to our system, we real time identify what are the machines which are available at this point of time. We send them the request that there is a customer who is looking for this part to be manufactured. Are you available to manufacture this part? The suppliers essentially bid, provide the costing, provide the feasibility, and all this information is provided to the customer using a tech platform. Traditionally, all these things are done using email and phone call and takes more than a week. But with this system, it's much more faster, it's much more agile. The customer get the best quote, and the moment they place an order, the platform takes the responsibility of manufacturing the part, the quality, and the logistics. Right? That actually brings a lot of trust from the customer to actually make a platform responsible for whatever happens with the order, right? So starting from managing the supplier, procuring the raw material, manufacturing the part, making the quality inspection report, till the parts are shipped to the customer and customer receives it. Entire thing is managed by the platform. While we are doing this, we are bringing some great advantages for our customers. The number one is flexible manufacturing capacity. So no matter you want to manufacture 1, 10, 100,000, 10,000 parts, these kind of network that we have built can help you in manufacturing part. So be it prototyping, be it batch production, you'll always find spare capacity in our network. The second is the deep supply insights that reduce risk. Because we are able to monitor the activity of each and every supplier that is connected to our platform, we know how responsive they are as well, which is a very non-tangible attribute which we want in a supplier. We want them to be responsive. So we have a lot of smaller insights that we collect about our supplier. We have a better understanding about them that helps us take a better decision. Transparency, because we are using the platform throughout the supply chain, and it's a single window for customers to manufacture parts. They don't have to talk to multiple people. The risk associated with the information leakages is also solved. This kind of network also bring advantages to the suppliers, right? They are getting new orders through the tech platform, which initially they don't have access to. Now they are able to get orders from cross country because it's a platform. People can place an order from US, Europe, other parts of the world, and can access the Indian manufacturing ecosystem, a system that was never existing before. They can get financial support because we are able to capture a lot of data about these job shops. We can also give them value-added services, right? And some of the unsaid advantages that comes with it is increasing the operational efficiency and capacity utilization. But all in all, if you look at it, this kind of network really, really helps the suppliers because this gives them access to the customer. This helps them in digitalizing their supply chain. This helps them in capturing the information that's happening onto the ground level. That all in all helps them get more business. And we are doing that across all the manufacturing processes. We are doing it for sheet metal, 3D printing, metal casting, CNC machining, injection molding, and vacuum casting. And we are very open to actually expand it to other manufacturing processes as well. Right? Uh, just a quick snapshot of what we have achieved so far. But before I end my presentation, just want to leave all of you on a very high note, thinking about how future of manufacturing is about, how it's going to go. And we know this is the process of manufacturing, right? You design a CAD, then there's some sort of manufacturing intelligence, which is again restricted to the companies right now. Then it's given to the factories to manufacture those parts. Then the quality inspection happened, and then the logistics. But if you look at it today, if you look at the trend, all of these vertical, each one of these vertical are getting impacted by new companies. And all of these companies are using cloud technology, right? If we talk about CAD, Onshape is a great example. I'm not sure how many people are using Onshape today, but it's really challenging the traditional companies like SolidWorks and Autodesk and likes of them. Shaper is another company where you can actually design a CAD on an iPad, right? Manufacturing intelligence and digital factories is where cloud manufacturing from true vendor perspective come in. We want to make a consolidated manufacturing intelligence platform where the information is not restricted to one company, but it's accessible to all the stakeholders. Digitalizing the factories. Once that is done, quality inspection. Now, quality inspection today is also a traditional process where a quality manager or quality engineer goes and inspect the parts. There are some smart companies like Landing Light, which is using machine learning and artificial intelligence to look at a part through cameras and just tell you whether it is quality approved or not. And lastly, the supply chain, the logistics part. And this is where Amazon has already entered here. I've heard that Amazon have deployed 3D printers into the trucks. So when you actually place an order on Amazon for a 3D printed part, they will actually manufacture in the trucks, then they're on the move and deploy it. Right? It's a very futuristic thought how the future of manufacturing and logistics can be. So as this as a future of cloud manufacturing, I think it's a huge scope for all of you to explore where you want to work. Um, and as a technical skills, I think uh, being a mechanical engineer today is not enough. I think we have to go beyond that and understand the new concepts of machine learning and artificial intelligence, learning few basic languages like Python that allows you to code and write some smart logics. If we are able to do that, I think a mechanical engineer today is not just a mechanical engineer, but a mechanical come software engineer. And that's what the industry is looking for today. Thank you so much, and would be happy to answer the questions. Thank you.
Thank you for the amazing session. It was really insightful. Hope you have learned a lot from this session.